Hey guys, Miss Blaylock here. We are getting ready to start lesson 1-3. I just wanted to say hey before I get started. The learning target for this particular lesson is going to be that I can convert between systems of measurement. So now we're going to take what we've learned in previous lessons about the metric system and about the standard system, and we're going to kind of mix and match with it. So let's go ahead and get started. All right, so as I said in the introduction, lesson 1-3 is going to cover metric to standard unit analysis. We're going to be converting between two different systems, focusing on metric units of measurement, which we talked about in lesson 1-1, and standard units of measurement, which we talked about in lesson 1-2. So there's not very many notes or any vocabulary for this lesson, which is nice. The only thing I want to point out is that converting between two systems of measurement, such as metric to standard, will always require some sort of conversion factor. The easiest way to set these problems up is going to be to do exactly what Mr. Thomaswick showed you in lesson 1-2, which is to use a ratio or a series of ratios that you're then going to multiply by each other. All right. We did provide you with some conversion factors. You will need to memorize these, but we tried to keep it simple for you, and we just gave you three main conversion factors that will help get you to whatever answer you need. These are approximations. There's no exact, or there's not an easily attainable exact conversion between them. So for length, we're giving you 1 inch is approximately 2 5400 centimeters. For volume, we said 1 gallon is approximately 3 79/100 of a liter. And then weight conversions, we gave you 1 kilogram is approximately 2.20 pounds. Just like you did with standard, you're going to want to set up your ratios strategically so that you're canceling out the units that you already have to get you closer to the units that you want. So, all right, hold still now. Okay, so for 120 pounds, converting to kilograms, we have a conversion factor that's already set up for that goes straight from kilograms to pounds. So we want what we've already got to be in the denominator now. So that's going to be my pounds. And then what I'm looking for is kilograms according to the problem. So 1 kilogram is equal to 2.20 pounds. And now because I'm multiplying and I've got this nice little cancellation happening here where my pounds and my pounds, because one's in the in the numerator and one's in the denominator, those cancel out and I'm left with only kilograms, which is exactly what I wanted. And now I can multiply 120 times 1 and I get 120. And then 1 times 2 20/100 is 2 20/100. Now, I'm going to use my calculator to do this division, and when I put that in the calculator, I get 54.545454 repeating forever. And you can round that or just tell the person looking at your work that it's repeating forever with this little bar on top. And the units on that are kilograms because that's the only thing left in my problem after I cancel everything out. All right, so that was way too easy. Let's move on to something that's a little bit more complicated. Example 2 wants us to move from from 4 feet to centimeters. So we know that we're starting with 4 feet and we're putting it over 1 just to make that multiplication of fractions a bit easier, but we want to go to centimeters. Here's the problem though. If you look back at the conversion factors we gave you, we don't give you any way to convert from feet to centimeters. So we're going to need an extra step to get us from feet to inches so that we can then get to centimeters. And this is where you're going to have to look back at some of the conversion factors that we gave you in the last lesson. Mr. Thomaswick did tell you that he wants you to memorize those. So it's going to be important that you use these two conversion factors. The one that's provided in these notes that goes from inch to centimeters, but also we need to get to inches from this 4 feet. So we've got 1 foot equals 12 inches. So I've currently got feet. So I need to put 1 foot in the denominator, and then that is equal to 12 inches. What that accomplishes is my feet are now gone, and I've got inches. And now I can go from those inches to the centimeters. So because inches is in the numerator now, I need to put 1 inch in the denominator and 2.54 centimeters. Okay, and now I'm ready to multiply straight across because you'll see that these inches cancel out and I can go multiply and be left with those centimeters. So again, I'm going to use my calculator for this because we want to use the tools that are available to us. And when I multiply 4 times 12 times 2.54, I'm left with 121.92. 121 and 92 hundredths. And the units on that are centimeters because centimeters are the only thing left over. So 121.92 centimeters. If I multiply across the denominator, 1 times 1 times 1 is 1. But anything divided by 1 is just that value back again. So my answer is that 121.92 centimeters. All right, so still not terrible if you know what you're doing. So let's go to our last example, which is the most difficult. Now we're going to be converting between rates. Converting rates works the same as converting between units. However, a rate is a ratio with 2 different units. So instead of having miles over just 1, we've got miles per hour. So I've got both miles and hours to work with. And in this example, they're asking us to convert 35 miles per hour to feet per second. So I'm going to have to do 2 things. I'm going to have to change these miles to feet. I'm also going to have to change these hours to seconds. So we're going to have several different conversion factors that need to get used here. And those are to go from miles to feet. We've got 1 mile equals 5,280 feet. But then to get from hours to seconds, we kind of have to take 2 steps. We first take hours and put it in terms of minutes. 1 hour is 60 minutes. And then we go from minutes to seconds. So each conversion factor that I plan on using has a spot, has a ratio that's going to get used. Okay? So let's first set up the problem. I'm going to deal with my miles first just to get it out of the way and change that into feet. So because miles is in my numerator, I want to have feet. So 5,280 feet. I'm going to make that look a little prettier for you. Okay? And that is equal to 1 mile. Now I'm going to deal with the minutes and seconds. I've got hours. Hours, notice, is already in the denominator, so I'm going to put 1 hour in the numerator when I start converting this. And 1 hour is equal to 60 minutes. And now I want to turn that minute into a second. So, because minutes currently in the denominator, I'm going to put 1 minute over 60 seconds. And I'm just using this conversion factor, but I'm deciding which thing to put in the numerator and which thing to put in the denominator by looking at what came before it and how I can cancel those out. So now I'm going to go through and just make sure everything cancels. Miles over miles, hour over hour. They're not next to each other, but notice there is one on the bottom and one on the top, which means they cancel, and then minutes and minutes. And what's left is feet, which is what the problem asked for, over seconds, which is what the problem asked for. All right, now I'm going to get out the calculator and multiply straight across my numerator. 35 times 5,280 times 1 gives me 184,800, oops, keep doing that, sorry. 184,800 feet. And then my denominator, I say 1 times 60 times 60, and that gives me 3,600, and my units are seconds. And my units are seconds. So I've got my feet per second, but I don't want to leave it in that format. So in my calculator, I'm going to put in 184,800 divided by, because remember fraction bars are just another way of writing division, divided by 3,600. And that is going to give me 51.3 repeating feet per second. And there is my final answer. All right, go ahead and start your practice. If you have any questions, be sure to raise your hand and let your teacher know.